Hey folks, all right, I just wanted to run through a couple of things that might help out with Lab 1. So again, this is kind of the follow-up to the first session for Lab 1. In that, we went through what the requirements for the lab itself are, we went through some basic Lisp, playing with it as an interpreter, playing with the scripts and whatnot. I just wanted to get a little bit into the functions and the recursion side of things today, since those will both come in handy for the lab itself. So let's see, I'm just going to run through a couple of coding examples, since I think that's probably the most effective way to get this point across. So what I wanted to do was to take a look at two simple example functions, one to just compute factorials, right? For the current lab, we're not playing with lists or anything like that, so the recursion is pretty much straightforward recursion. It's just getting the error checking base cases and general cases handled in Lisp. And so I just wanted to run through a couple of examples of that. So we'll play with defun and with cond to kind of get our point across. So the first one, just computing factorials. What have I got here? So again, basic idea is, I want to create a function that's going to take a single value that's supposed to be a positive integer and compute, n factorial. So n times n minus 1 times n minus 2 times blah, 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 blah times 1. So again, I've thrown in the little documentation string there. So it's supposed to return n factorial if it's a positive integer. We'll return nil otherwise. And so what I'm actually going to do is I'm going to have, if they've passed an invalid value, I'll have format print out an error message, since format also returns nil by default. So that way it returns the nil and they get an error message telling them what went wrong. So again, for cond, this is essentially the most common way for going through and checking if this, else if that, else if that, else if that, else if that, else. Right? So what we're going to do is eliminate the possible errors first. So we'll check if n is not an integer, and if so, we'll display an error message and return nil. Then if we get past that, we'll check if n is less than 1, and if it's less than 1, we'll display an error message and return nil. And then we'll check the base case, right? If n is 1, then we just want to return 1. Actually, if n is 2, we just want to return 2 as well, the way it works out, right? Since 1 times 2 is just 2. So what I'm going to say is if n is less than 3, we'll return n. And then the general case, we want to take n and multiply it by the factorial of n minus 1 to get the overall factorial. So we'll make this recursive call. So again, with cond, the idea is we have the condition to check first, and if it's true, the value to return. Right? And so we've just got this whole sequence of pairs, right? Each cond is a pair that's a condition to check and what to do if that condition is the true one. And so it'll just return the result of the first true thing it encounters. So if it's the case that n is not an integer, so we'll check if n is an integer, invert that. So if n is not an integer, we'll tell them an integer was expected, not the value you gave me, whatever it was. And again, the format's going to return nil. So if we get past that, we'll check if n is positive or not. So if n is less than 1, then we'll tell them, oh, no, I expected a positive value greater than 0. And again, the format will return a nil. We get past that, we'll say, okay, well, was n less than 3? So if n was a 1 or if n was a 2, we'll just return n. And then the general case, right, our else case, will compute n times, and we'll make our recursive call, right? Compute the factorial of n minus 1. So we get n minus 1 factorial, multiply that by n, we get n factorial. So again, it's pretty straightforward, right? But this is going to be the typical recursive structure you're going to have. Any error checking for the parameters, and then any base cases that you need to handle, and then any general cases that you need to handle, right? And that gives you a nice clean structure. And again, as far as layout goes, I typically, for my functions, I just throw in however many brackets I need to close off the thing on the end. Now, I do highly recommend picking an editor that does bracket matching for you. It makes life a whole lot simpler in Lisp. But let's give this a try. So I'm going to try this out in the interpreter just to have a bit of a play with it. So I'll run my GCL. And again, remember that load loads whatever Lisp file we've got here. So I'm going to load factorial.cl, so that'll load my function definition. And then I'll just try some of these out, right? So we'll try factorial of foo. And hopefully it gives me an error message and doesn't blow up. Okay, integer expected, not foo. So then we'll try a factorial of, a negative number. Now let's try a real instead of an integer. And again, integer expected, not 3.14. Let's try a factorial of a negative number. Right, positive value expected, try factorial of 0. Again, we get our error message. We'll try a factorial of, let's say, one of the base cases. Yeah, that looks okay. We'll try a factorial. And again, we'll try some larger values. So factorial 5 should give me 5 times 4 times 3 times 2 times 1, which should be 120. All right, so that works out okay. And again, that's going to be a pretty common structure, right? Our maybe a documentation string, right? Our defun function name, parameter list, check the parameters are valid, right? Check the types are valid, check the values are in whatever range restrictions we might have, check any base cases for our recursive solution, and then check the general case. All right, I just wanted to play with one more example here. And so for this one, what I'm going to do is ask the user to enter a real number. I'm going to read whatever it is they give me. And if it is a real number, I'll return it. If it's not a real number, I want to give them an error message and get them to try again and keep this going until they do give me an error message. But what I want to try is to do this in kind of Lispy fashion. So we'll try doing this without using local variables. So, ordinarily, you typically do something like prompt the user, read their value, store it in a variable, check if it's valid or not, and then either get them to try again or return the value. But since we want to use that value in the error message or make a recursive call, it gets a little tricky if we don't use local variables. So I want to show you an idea for a solution here. What did I call this? Get real? Yay. So again, this is basically the idea. I want to get a real number from the user, keep trying until they actually give me a real number. I'm going to try this with recursion and no local variables. So what I'm going to do is throw in a couple of extra functions, helper functions to use to do this. So for my getReal function itself, all it's going to do is prompt the user, please enter a real number, read it in, and then pass that off to another function to try doing all of the error checking and retries and stuff. So again, just a documentation string here, and then we'll prompt the user, enter a real number. This isn't, truly pure functional programming, since I do have some sequential steps in here. I'm doing my format, and then I'm doing the call as a secondary step. But at least we're playing with getting rid of the local variables here. So prompt the user, enter a real number, and then I'm going to read it, right? So I'm using read to read whatever it is they enter, and I'm passing it off to another function to go off and check whether it's real or not, and somehow that will take care of going off and doing the repeats if we need to, error messages and repeats. So my second function here, my check if it's real, right? This is getting the number that they read in. So this read a value, passed it off. So whatever they typed in is now in n, but it may or may not be a real number. So again, just a documentation string here describing what the function does. And then what I'll do is check n here. So if n is real, I'll just return it, right? That's the answer. They gave me a valid thing. I don't need to retry. But if n wasn't real, then we'll call retry and pass n off to that. All right, so now we get our third function. Retry. So here we've passed it whatever they entered that wasn't a real number. So this is our bad value of n, if you like. So again, a little documentation string here, just describing what the function does. So I'll give them an error message, that was not a real number, whatever it was they typed in, please try again. And then I'll go back to calling getReal all over again. So this will start the cycle anew to go off and, prompt the user, get a real number, blah, 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 blah. So this will create my cycle. This is where the kind of mutual recursion comes in. If they enter a good value, then we've called getReal, passed it off, it's valid, so it comes back and gets returned. If they enter a bad value, right, we read it, pass it to checkReal, that passes it to retry, that prints the error message, and goes back to getReal for the subsequent attempt. So this should actually work out okay. We'll, again, try this out in our interpreter here. So we'll load getReal and give things a try. So it looks like no syntax errors. So we'll just try calling getReal. And again, it doesn't take any parameters, so it's just the name of the function. It asks me to enter a real number, so I decide, no way, I'm going to enter foo. So I get my error message. That wasn't a real number. It tells me what it was. Please try again. And it makes the new call to getReal. And so I try again. I'll enter X. That wasn't a real number. Please try again. So we're going through this recursive cycle. And eventually, I enter something that is a real number. And it reads it, returns back through that sequence of function calls, and eventually coming back to give me the result. Yeah, so it does work out okay. So again, we can work quite happily without using any local variables, but it does often wind up with this kind of need to introduce secondary functions to say, okay, well, if I want to use n multiple times in a sequence of statements, then typically the way we'll do it is to pass n as a parameter to something that uses n multiple times. So if I wanted to say if n is real, return n, otherwise retry it. All right, that would have been a problem to attempt here if I'd said, if I wanted to read the value, check if it's real or not, and either return it or make a recursive call. All right, since I just have that one call to read, I couldn't make multiple calls to read, because then I'd be reading different values and passing different values off in places. So this idea of introducing an intermediate function as a way to store that value and use it multiple times is a pretty typical solution. Now, this isn't something that you specifically have to do for the lab, but since we're getting into our playing with recursion, this is a good place to stop and think about how we can do things when we don't have local variables, right? We haven't gotten into talking about let blocks yet, which will introduce local variables, and the lab tells us we're not allowed to use global variables in our functions. So if you do find yourself in a scenario where you really want to use a local variable, this would be the solution to get around it. All right, that was pretty much everything I wanted to go through there. Again, I don't think anything in the actual lab itself should be too much of a challenge. It's basically getting through the Lisp syntax and playing with the recursive style of things and getting used to our type checking and whatnot. All right, I will leave it there for now and see how we go.